Metal G or Bug Jew, a red beast star. Almost there, Jew, a red beast star. It is a cosmic marvel, expecting that you put it where the sun is, it would reach out to the circle of Jupiter. It's colossal, altogether sensitive, and it's going to explode. Get ready for a huge disaster of never-before-seen scale. Betelgeuse, the red Goliath star on the edge of our grandiose framework, is passing on alarming messages through space. Cosmologists have followed down something significantly upsetting about this enormous item using the James Webb Space Telescope. Renowned scientist Brian Cox has given an extreme reprobation. The inquiry that keeps on coming up is, are we going to notice an enormous blast impact that will change the night sky forever? The puzzle of Betelgeuse. In the boundlessness of the universe, stars are imagined, live, and die in dumbfounding ways. Actually, one star has gotten the eye and stress of both space specialists and everybody. Betelgeuse, a red supergiant star in the heavenly body Orion. It is incredibly tremendous and old. Its exceptional ruddy assortment and evolving magnificence have for quite some time been spellbinding. Yet, late events have elevated interest in this tremendous beast. As we figure out more about Betelgeuse, we are extremely close to a potentially extraordinary event in its set of experiences. However, what could these progressions in Betelgeuse mean? Are we seeing the beginning of an amazing show on an inconceivably huge scale? Betelgeuse's colossal size and life cycle. Betelgeuse is a grand monster multiple times greater than our Sun. Its size is almost beyond human capacity to get a handle on. Imagine a star so huge that, assuming it superseded our Sun, its surface would extend past Mars' orbit, wrapping Mercury, Venus, Earth, and Mars. This tremendous size not only describes the true significance of Betelgeuse but also shows its stage in the stellar life cycle. As a red supergiant, Betelgeuse is drawing closer an astounding finish, expanding and cooling after exhausting the hydrogen in its center and joining helium. The age and advancement of Betelgeuse. This star is estimated to be somewhere in the range of 8 and 8.5 million years old. While somewhat youthful in human terms, it is old in vast terms. Over more than millions of years, Betelgeuse has gone through profound changes, developing from a hot blue star to the red Goliath we notice today. It is now in its final stage as a red supergiant. Stars like Betelgeuse change throughout their lives because of the continuous strains of nuclear fusion and gravity. Another brand name that makes the period of Betelgeuse noteworthy is its wonderful reddish color. Its red tone arises from its cooler surface temperature compared to other stars like our Sun. Its brilliance changes, and historical records show that the Sun's surface is around 5,500 Kelvin, while Betelgeuse's surface is around 3,500 Kelvin. This cooler temperature allows Betelgeuse to emit light at frequencies that cause it to appear red. Anyway, this tone is something other than an appearance. It uncovers data about the star's actual state and the processes occurring inside its colossal gaseous volume. Betelgeuse's color change over time. The fact that Betelgeuse's color has changed over time adds to its mystery. Historical records from Roman and Chinese times show that Betelgeuse was yellow as recently as 1,000 years ago. By the 9th century, Arabic astronomers noticed its red color. This shift over the course of human history isn't just a historical reference. It means the star's development. The unbelievable diminishing event. Another intriguing piece of Betelgeuse. Another intriguing piece of Betelgeuse is its changing quality. It is a semi-regular variable star, meaning its brilliance varies occasionally. This melodic darkening and lighting up have thrilled scientists and astronomers for hundreds of years. Regularly, Betelgeuse undergoes a multi-day cycle and a longer 5-year cycle. As soon as 1836, Sir John Herschel documented these cycles, and local individual stories might go back even further. However, what truly makes Betelgeuse weird isn't just its brilliance changes but their irregularity. Dissimilar to many stars that vary in brilliance regularly, Betelgeuse sometimes goes astray from this example, suggesting confused and less figured-out processes inside its tremendous construction. Surprising observations and later developments. What's more, later improvements. Recently, space specialists and astronomers were staggered to notice an emotional and startling change in Betelgeuse's appearance. This wonderful obscuring has raised various types of hypotheses. This is now known as the extraordinary darkening. In late 2019, the red supergiant Betelgeuse, one of the most brilliant stars in the evening sky and a noticeable element of the heavenly body Orion, began to decrease bafflingly. The star was diminishing so rapidly that it started losing its light at a speed of 0.01 magnitudes each day on average. By February 2020, it was at its dimmest. Strangely, Betelgeuse, which can normally be seen with the naked eye, even in regions with significant light pollution, turned out to be much fainter, and even casual onlookers could see the difference. The mystery of time and light delays. However, the time mystery entangles observations of Betelgeuse's activities, as light takes such a long time to reach us. When we notice a star like Betelgeuse, we are not seeing it as it is now but as it was in the past. For Betelgeuse, the light we see today left the star almost 725 years ago. This delay makes predicting and noticing quick changes in its behavior challenging. Andrea Dupree, the deputy head of the Center for Cosmology at Harvard and Smithsonian, and her group closely observed Betelgeuse's superb show as part of a 3-year study to follow changes in Betelgeuse's outer environment. They used the Hubble Space Telescope to observe the enormous star. These observations gave new insights into how a variable star like Betelgeuse works. The Hubble Space Telescope and the mystery of Betelgeuse. Variable stars continually develop and contract, causing changes in their brilliance. Researchers were able to look at the layers above Betelgeuse's surface, somewhat heated by the star's swirling convection cells. Thanks to Hubble's aversion to ultraviolet light, further analysis of Hubble spectra taken at different times in 2019 and 2020 revealed the improvement speeds in Betelgeuse's upper atmosphere, the release of material, and its outcomes. The spectra were primarily made out of magnesium, showing that material was moving from Betelgeuse's surface into its atmosphere at around 200,000 miles per hour. The emission and mass loss of this hot, thick material ultimately traveled thousands of miles from Betelgeuse, forming the dust cloud that obscured the star during the 3 months of emission. Dupree and her team estimated that about twice as much material was ejected from Betelgeuse's southern hemisphere. While all stars lose mass over time, Betelgeuse's mass loss was particularly prominent because it happened at a much faster rate than the Sun's. Cosmologists considered whether this event could signal a looming cosmic explosion, given the size of the mass discharge and the resulting darkening. Being almost 725 light-years from Earth, Betelgeuse adds to the interest, as any such impact would be recognizable from Earth and offer an intriguing opportunity to study a supernova up close. Betelgeuse's future. Yet the question remains, what does this darkening mean for Betelgeuse's future? Is it a sign of an inevitable cosmic explosion? Or is it simply a one-time event in the star's long and complex life? Several hypotheses have been proposed to explain this rapid change. One popular theory suggests it was a precursor stage in the supernova process, gaining speed due to the belief that Betelgeuse is approaching the end of its life. Another hypothesis suggests that dust, potentially from the star itself, was blocking our view. The fact that Betelgeuse and other red supergiants shed material, which could gather into a dust cloud thick enough to block the star's light, is one possibility. A third theory examined how changes in the star's photosphere, the visible outer layer, could influence its apparent brightness. This mystery was addressed using a blend of observational strategies and in-depth analysis. Spectroscopic examinations and findings showed that Betelgeuse's effective temperature had decreased, suggesting that the star might be dimming due to a huge dark spot on its surface. The fact that Betelgeuse's temperature dropped by at least 170 kelvins around the time of the darkening supported this idea, showing massive changes on the star's surface. The role of the Hubble Space Telescope. Ultimately, the Hubble Space Telescope, humanity's sentinel in space, helped us understand what was happening with this rare event. Hubble's observations showed that the darkening of Betelgeuse was likely due to a large amount of hot matter being launched out into space. This material formed a dust cloud that obscured part of the star's surface, diminishing the amount of light reaching Earth. The dust cloud was thought to consist of very hot plasma that radiated from large convection cells on the star's surface. As this plasma traveled through Betelgeuse's hot atmosphere to cooler outer layers, it formed dust grains that made a cloud obstructing light from about a fourth of the star's surface. The impact of the ejected material. The impact of the ejected material was apparent from Hubble's ultraviolet light spectroscopic assessments, which began in January 2019. These assessments were crucial in understanding the events leading to Betelgeuse's dimming. They identified thick, hot material traveling through the star's atmosphere months before the dimming. Some ground-based telescopes also observed the star's brilliance decrease in December 2019, with Hubble's observations confirming these findings and providing further insights into the ejected material. The future of red supergiants. The discovery that Betelgeuse was losing material at a much faster rate than previously thought led to the realization that this rapid mass loss could influence our understanding of stellar evolution, particularly in red supergiants. Red supergiants in stellar evolution. It's important to understand that Betelgeuse isn't the only star going through such dramatic changes. Other famous supernovae, such as SN 1054 and SN 1987A, have provided valuable insights into how stars die and how new elements are formed. These previous events have helped shape our understanding of stellar deaths and their influence on the surrounding space. For example, SN 1987A, which happened in a neighboring galaxy, offered a close-up view of a supernova explosion and its aftermath. Such supernovae contribute to the cosmic cycle by dispersing heavy elements and impacting star formation potential. The impact of Betelgeuse's potential supernova. The impact of Betelgeuse. If Betelgeuse eventually becomes a supernova, it would create a grand light show visible from Earth. The explosion would be brighter than the moon and could even be seen during the day. Such an event would offer an incredible opportunity to study the final stages of a massive star's life, as well as the development of large structures and the spread of heavy elements across the universe. Despite the dramatic nature of a supernova, the distance between Betelgeuse and Earth provides an endless safeguard, ensuring that such an impact is unlikely to directly harm us. The insights gained from observing Betelgeuse's potential change will continue to advance our understanding of stellar evolution and astronomical phenomena. The role of red supergiants in stellar evolution is crucial to our interpretation of cosmic development. These stars represent the final stages of a massive star's life cycle before it undergoes a supernova explosion. Their immense size and relatively short life expectancies make them excellent laboratories for studying the end stages of stellar evolution. Red supergiants play an essential role in understanding how massive stars evolve, as well as the processes that lead to their catastrophic deaths. These stars have a tremendous effect on their surrounding environments. The energy they release in their final stages contributes to the formation of heavy elements, which are fundamental for the creation of planets and life as we know it.